I want to welcome you to another class. Today, our focus is going to be on research design, but specifically, we'll be focusing on observation and studies. The last time we met, our discussion actually centered on experimental studies. And today, we're going to move away from that. We want to consider another studies, okay? And I'm actually going to walk you through uh, the benefits from using the studies and the reason why it may be it may not be feasible or unethical. Okay, it may not be ethical to conduct experimental study. Okay, why we choose observational studies. I'm actually going to walk you through all of that. Okay, so I'm going to say this. The facts remain that experimental study has huge statistical power. And the reason why experimental studies have statistical or huge statistical power is because of the fact that we're able to follow the principle of experimental design, the principle like randomization, blocking, and so on like that. But the most important of that is randomization. So randomized experiments is actually expected to have a very strong statistical power. And of course, we can actually use that to conclude on causation. Okay. But there are situations that I'm actually going to identify today, okay, that may be impossible for us to go by way of experiments. Okay, so why we need to go for observational study. So I'm actually uh, going to unravel that into this lecture. At times, it may not be feasible, it may be unethical, and it may even be impractical to go for experimental study. Okay, so I will let you, but let's come to observational study. So, you know, instead of us to randomize treatment, instead of the researchers to actually have a control, okay, on the explanatory variable. So what researchers do here is just to observe any differences in the explanatory of variable. So the researcher is actually going to use historical data. Okay, they're going to base their decision on historical data. They are not going to be the one, they're not going to have any intervention. Okay, they will not assign uh, participants to treatment. Okay, so and because of that, because of the fact that they're not able to do that, then whatever or whatever result that we got with the observational study, we cannot use it to answer problem that has to do with causation. And that was why I said, cannot be used to establish cause and effect. But let me tell you this. I'm going to walk you through today. Uh, if we're able to implement some strategy, we can still use observational study to answer a question of causation, but we have to do a lot. Okay, so for you to understand, to follow my explanation about researcher only observing differences in the explanatory variable, What do we mean by explanatory variable? What do we mean by response variable? Of course, when you have your data, okay, uh, we have your data in a spreadsheet. At times, you collect your data over variables. One of the variable could be explanatory, the other could be response. So you could have so many explanatory variables that I also call independent variables that we also call features in machine learning. And you have one particular outcome variable that we also call response variable. So as far as research is concerned, explanatory variable has several names. We can call it treatment. If you take a look at this, we can call it intervention. We can call that exposure. And we can also call that risk factor. Okay? So why the response variable, we can call that outcome variable. You know, some researchers also call that dependent variable. Okay, just wanted to take note of that. Okay, you know, I said something the other time because of the absence of randomization, because of the fact that researchers only observe, okay, the researcher did not manipulate explanatory variable, okay, we're not able to conclude on causation. But if we put necessary machinery in place, okay, uh, we can actually go from association to causation, okay, because you know, when you talk about observational studies, okay, we talk a lot about association. Association is relationship or correlational, okay, but you know what? Association does not imply causation, but I'm just still going to walk you through how we can actually go from association to causation even with observational studies. But you know what? I need to for us, you know, show you that the difference exists between association and causation. Okay, I'm going to cite these three potential scenarios. Okay, there's a particular scenario where A is causing B to change. There's another scenario where B is also causing A to change. And we have another scenario where there's a particular hidden variable that is causing A and B to change. Okay, if I want to match this scenario with what I have here, please, I need you to pay attention now. Let's talk about, for instance, we conduct a study. We actually want to investigate a relationship between temperature and ice cream sales. Okay. Now, when you take a look at you know, this, it makes sense to say when there is high temperature, particularly in the summertime, we expect the more sales on ice cream. Okay, so if you look at that scenario number one, okay, I can actually say that. Okay, let me see if I can use this. Give me 1 second. I can actually say, okay, you know what, this guy, actually go with this guy. Oh, sorry. Let me do this. This guy, actually go with this guy. Okay, because A is uh uh A is temperature here, and B is ice cream. So you know, depending on what values of temperature, I mean what season that you are, that will have effect on the ice cream. Okay, but let's take a look at uh you know, I've talked about these three now. Okay, and if you talk about this guy here, of course that would be B causing A, right? Here, A causing B, right? The two are more or less the same. It's just a change of alphabet. But the one I want to specifically talk about, the one I want to talk about, I need you to pay attention, is actually this guy. Okay, I want you to pay attention to that. If you collect your data on ice cream sale and the crime rates, and you observe that there's high correlation, okay? You observe there's high correlation between ice cream sales and crime rates, okay? You cannot conclude that the ice cream sales actually cause the crime rate to happen, even though they are associated. Okay, if you really want to actually, and the reason why the association occur is because there's a particular hidden variable that is actually affecting both. Okay, there's a particular hidden variable that I'm actually going to call confounding variable that is actually influencing both ice cream sales and crime rates. Can somebody tell me what that hidden variable is going to be that may has a tendency to influence ice cream sales and crime rates? Exactly. Thank you so much for sharing that. That's temperature. Now, if in research, if if association exists between two variables, before you can conclude on causation, you have to make sure you control any variable that may have a potential, they have a way to influence both. If you don't control that, then your conclusion is not going to see the light of the day. And that is what I'm trying to say here. Look at that. C causing both A and B to change. So C here is temperature. Okay. So here is temperature. If you are working with other studies, you need to be able to identify, some hidden variables that may also be influencing the outcome. Okay. Now I need you to see this. It is an established fact that, we may not be able to establish a causal relationship, okay, from observational studies. But when we know, for instance, if our goal is a causal goal, if we are seeking a causal goal, okay, and we know that observational study may not be able to achieve that, then why can't we go for experiments? Okay, and I'm actually going to tell you the reason now. Even though we know experimental study is actually going to translate into a very strong statistical power. But why not choosing experimental study? But I'm going to tell you, we also have reasons why we may not go for experimental study. Okay? And I mean, you're going to see the reason now. Let's take a look. It depends on the study. Take a look at it. If you take a look at that study now, you actually want to investigate. Okay, you want to investigate whether addedness affects mortality. Okay, now for you to use experimental study, you have to randomize treatments, right? There's no way you can assign addedness. You can't ask some people to be left-handed and some people to be right-handed. That is to me is probably if somebody want to it's as an early life thing, early life, let me write it. That's an early life thing. Okay, that's an early life thing, early life. Okay, so what I'm trying to talk about is that the left-handedness or the right-handedness cannot be assigned. There are some treatments that cannot be assigned They are just attributes. So, if I want to use an experimental study here, it may be impractical, it may not be feasible, okay, even though I know it's appropriate, okay. So for study one, okay, we got no choice. We have to go by the way of observational study. Let's take a look at study number two. Okay, maybe you want to investigate the effect of smoking during pregnancy on the child intelligence quotient. Now, if I want to go by way of experimental study, I need to look for, uh, you know, expected mothers, that they've not smoked before. I will have to assign them to smoke. Okay, and despite the fact that I know that may be harmful, that is unethical. Okay. So assigning mothers to smoking treatments, that's unethical. So what I'm going to do here, I will just go into historical record. Okay. Maybe we have a record of mothers and who smoke and mothers who do not smoke during pregnancy. Okay. And we also have a record of the IQ of the children. Does that make sense? Okay, so we got no choice. We're going to go by way of observational studies, okay, to be able to answer that scientific question, because we to go by way of experimental study, of course, because because that is unethical to to do that. Okay, we can't do that. I want to go to study three. Investigating whether taking aspirin reduces the risk of heart attack. Of course, this can be achieved by experimental study, okay? But the only issue that we're going to have here, if you look at heart attack, is a rare event, okay? Which means we're actually going to, the follow-up is going to be forever. We're going to wait forever because we have to wait for the outcome to happen. And that is actually going to be costly waiting. Don't forget we're spending. Okay, while you are waiting, you actually there's a cost that comes with that. And that was why I said potential effects on heart attack take many years because it's a rare event and costly in time and resources. Don't forget, when we are conducting research, we are limited by budget. Okay? So that's why it may not be feasible here, okay, to actually conduct experimental study, even though we know is the most appropriate. So we have to settle for second fiddle, okay? And I said here, may not observe enough outcome with rare event, which means you need to conduct a very large randomized experiment before you can observe the occurrence of the outcome. Okay? Okay, now I want to move right now. Now, because we're still pursuing COSA goal, we actually want to have a conclusion on causation. And because the fact that because of ethical issue and you know cost expensive resources and stuff like that, can we have a way to translate our association that we observe in observational study into causation? What do we need to do? Okay. Now, what we need to do is if we have a very strong design, okay, with very strong evidence, okay, we can actually conclude on causation with observational study. A very good design, okay, and a very strong evidence. We can actually conclude on causation, okay, and I'm actually want to walk you through the uh, you know, the intervention here. Okay. Now, and that's what I'm saying here, a good study design, okay, with a very strong evidence. And the good study design we eliminate or reduce confounding. Don't forget the other time when I was trying to look into a relationship between ice cream sales and criminality, okay, uh any association, any relationship that occur may not be translated to causation because of the fact that there's going to be confounding variable. Okay, there's a particular hidden variable that need to be controlled that may be influencing both. Now, because of that, this is what we're going to do. One of the steps, okay, in your design, if you want to have a good design, what you need to do to achieve causality with observational study, we need to use matching. Matching, okay? We need to use the technique of matching. And this is what I'm going to do. And I need you to pay attention. Let's say, for instance, I want to study I want to study the effect of smoking on the risk of getting lung cancer. Okay, and I can assign. Maybe I don't want to assign. Maybe it's unethical for me to assign participants that have not smoked before to start smoking. Okay, and I want to go by way of observational study to do that. But I know that we have issue with observational study. The issue we have with observational study is that there could be some other potential variable that may be influencing relationship between smoking and the risk of getting lung cancer. Okay? And that is why we need matching. The matching is going to ensure that those who smoke and those who do not smoke, the only difference between them is the fact that they smoke and some did not smoke. We actually want to control other potential variables that may be influencing them, like age. Okay, like if you talk about age, if you talk about gender, if you talk about socioeconomic status, okay, so all of those variables are confounding variables. They actually need to be controlled. And what I'm going to do, the matching is not going to say, okay, if because I'm going to have two groups, I'm actually going to have two groups, okay, in this group, okay, yes. In this group, yes. Yes group, that is the smoke. Okay. In this group, no. Okay. And I want to make sure here the participant I put here, the participant are different, they are matched. Matched in the sense that they have more or less the same socioeconomic status, they have the same age, they have the same characteristics or any characteristics of interest I can think about. That's what I call matching. Okay. And that is exactly what I'm talking about here. Okay. Match up individuals in the treatment and the control group. Okay. In some characteristics to make the two groups comparable. Okay. Because on a day one, if you go to court, if somebody go to court, that if they accuse this person of wrongdoing before the court, okay, at the beginning of proceeding, okay, they're going to assume is the court need to be fair. Okay, a court shouldn't be one-sided. Okay, so what we're trying to say, we're putting them at the same level, so that the only difference that occur between the two groups, it should be due to treatment only, not due to any other variable that we can talk about. Okay, that's all I mean. Okay, that's what I mean by that matching. Okay, and if you take a look at this, if you take a look at this guy here, I said, please pay attention. I said, what characteristics need to be matched up? If you are working with observational study where you actually want to conclude on causation, you need to review literature to be able to know what are the possible variables that may likely influencing your variables. So here, if I want to work on investigating how smoking affects the risk of getting lung cancer, I have to go to literature. I have to read different articles, okay, to be able to identify what potential variables that I need to, consider as confounding factors. Because the confounding factors are those one that I'm actually going to match. I need to put that into consideration to match the participant. Okay, now let me tell you this. I think there's an epidemiologist. His name. Give me 1 second. I think his name is Sir Austin Bradford E. Okay, Sir Austin. Let me see if I can actually write it down. Give me 1 second. Okay, so this guy is an epidemiologist. He gave us some kind of criteria. Okay, uh, because when you take a look at matching, okay, um, that is actually costly as well because I have to look for individuals that will have the same characteristics, okay, and that's why Sir Austin Bradford Hill in 1965 in his paper, okay, he actually suggested criteria, that can guarantee causation, conclusion from association, okay. Now, there's a lot of them, okay. There's a lot of them. Number one is temporality. Number two is the strength of association. Number three is biological plausibility. And number four, consistency. We also have coherent. There's all like that. I just want to brief you on this. Okay. These are kind of guidelines. Okay. Like set of rules or criteria, that can actually distinguish causal from non-causal association in observational studies. Now let's talk about number one, temporality. Okay. Now, what does temporality talk about? Temporality is trying to say, if I want to answer a question that has to do with causation, then I need to believe that exposure happened before the effect. Okay. Exposure have happened before the effect. Okay. So which means something has to happen before we can link into something. Okay, so that's why we have that as exposure happen before somebody can have a risk of getting a disease. That person must have been exposed to that disease as given by Austin. Okay, and that is what we call temporality. Okay, so in the case of that, I said smoking must occur before the risk of getting cancer. Okay, so that's exactly what I mean. But let me tell you this. If you take a look at ice cream sales, okay, and criminality, okay, temporality does not apply. So do I need to say ice cream before somebody commit crime? It doesn't make sense. Okay. So in the case of looking into those variables, another thing is the strength of association. Let me tell you this: when you conduct statistical analysis, you are trying to investigate relationship between two variables. Okay. Now, the strength of relationship, you can determine that probably through the p-values. Has everybody heard about p-values? Okay, if I want to investigate statistical significance, of course, I make use of p-values. Okay, so the strength of association actually matter, or maybe you want to talk about I values of R squared, well, that we call the goodness of fit, and so on like that. So, but let me tell you this, individually, when the E criteria is satisfied individually, it is not enough. We want situation where most of these criteria will be satisfied simultaneously before we can actually conclude on causation. Okay, so that is exactly what I mean. Now, let's talk about, and that's why I said strong association are more likely to be causal than weak associations. Let's talk about biological plausibility. Okay, you know, biologically, there must be an argument. There must be a way to link, a cause to effect. There must be a way to link that. There's something that I actually come across, you know, when it comes to tobacco smoke. Tobacco smoke contain carcinogens. Okay, so talking about biological plausibility, okay, uh, tobacco smoke actually have carcinogens, and biologically, carcinogen can actually cause a damage to DNA, and of course, when there's a damage to DNA, that's could cause cancer. So this is what we call a biological linkage, okay, between the cause and effects. Okay, so I just want you to take note of that. And another criteria in the EU causality is what we call consistency. Okay, here I said, always observe this association under different circumstances. What I mean, under different circumstances, in every location. Like if I investigate relationship between the variables under investigation, in the United States, I'm going to get the same result. If I go to Africa, it's still going to be the same result. If I go to Asia, irrespective of location, if I'm able to establish that same fact. That's what we call consistency. Not only in different location, even across populations. When I say across populations, okay, whether I use black, white, or whatever is still the same across populations, okay, and not only that, across designs. If I use this design, I got the same result. I use a different design, I have the same result. Then that would be called, if that is actually fall under consistency. Now, apart from like I said, there's so many of that. Apart from consistency, we also have coherence. There's so many coherence. Okay, we also have coherence. Okay, so apart from consistency, we have coherent situation, or whereby maybe somebody conducted the research unknowingly to me, and I conduct the same research, and we got the same result. Okay, so there's a coherency. Okay, there's so many other the criteria, but I think I'm going to restrict us to this. But there's something that I mentioned here. The more criteria you satisfy, the better. Okay? So just satisfying just one criteria may not be sufficient. Okay? And also I give example here. Okay? If there's association, a strong association between ice cream sale and crime rate, okay, but we know that their relationship is not causal. Okay? So That's even stronger because the strong association will fall under the strength, right? Under the strength of association. But that one alone is not sufficient. Does that make sense? Okay. Now that you understand observational studies, and I want to walk you through different type of observational studies. We are what we call, we can categorize, based on, if I want to categorize observational study based on the response outcome happens, okay? We have that categorization, okay? And we may also categorize it based on how we choose sample size. Has anybody heard about sample size determination? Okay. Now, if I, right now we're talking about types of observational studies. We want to look into that when we categorize based on when the response happen. When I say response, when the outcome happen. Okay. When the outcome develops. Okay. Then we're going to consider two types based on that. We're going to consider retrospective study and prospective. Okay. Now, when you take a look at retrospective study, it's like looking backward. Prospective is looking forward. Okay. Now, by retrospective, okay, the outcome has already occurred. But you now, it's like, oh, somebody have a lung disease. Okay, we know that already. But we now want to look backward to see what was responsible for that. That's what we call retrospective. Okay, observe the outcome using past record. Okay, so, but when you talk about prospective, somebody right now is being exposed to one of the risk factor, and I'm actually going to wait to see whether outcome will develop. Okay, there's possibility somebody could get exposed. Outcome may develop, outcome may not develop. Okay, and that's what we call prospective. Okay, so retrospective and prospective, they actually fall, okay, under observational study that is based on when the response or outcome happens. In one, can see that. Okay, now I want to go into another categorization of observational study, which is based on the way the way we sample. Okay, how the sample is collected, and I need you to pay attention. Why we give you this information? Because you're still going to perform an independent research in this course, and you need to be guided. Okay, that's why I'm disseminating this. Okay, so if I want to base it on, you know, if I want to base it on the way the sample is taken, we have what we call cohort study, we have case control study, and we have a cross-sectional study. Okay, now I need you to pay attention to this. Okay, now are we sampling with the respect to outcome or the exposure? Okay, so we want to put that into consideration. Okay, we are sampling with respect to outcome or exposure. For instance, if you take a look at the outcome, if you take a look at this one, if we are doing that with respect to outcome, then that would be case control study. If we are doing that with respect to exposure, that would be cohort study. If we are doing that, if we're not doing that based on any of that, we're actually going to call that cross-sectional. So therefore, you need to be able to understand the type of study even within the observational study. Then what I want to do right now, I actually want to walk you through this. Please pay attention. Okay? I need you to pay attention. I still want to make use of the example how smoking affects how it affects lung cancer. Okay? I have two major variables. The two variables that I have are categorical. If you take a look at that, they have labels. Take a look at this. Okay. Exposure is explanatory variable, is categorical. It's either somebody smoke or not. That's two levels. Outcome is also categorical. It has two levels. It's either the event of interest develop or not. Okay. Now I have two categories of this variable. I have two categories of the other variable that I'm actually going to use a contingency table. What do we mean by contingency table? Is what I have here. That's what we call contingency table, where categorical variables are being actually classified. Now, take a look at this. I want to talk about case control study. That is when I'm sampling with respect to outcome. What do we mean by sampling? With respect to outcome, that is, I already know that 25 people, okay? If you take a look, have the disease. Take a look at this. 25 have the disease, and 25 do not have the disease. When I sample, okay, my sampling is intentional. I'm actually focusing on those who have already developed the disease and those who do not. That is what we call, case control study. Okay. Now, this is what happened. Those who actually have the disease, okay, they are 25. Those who do not have are 25. Now, and I want to ask a question from them. The question is, or that I'm going to ask all of them, do you smoke or not? Okay. And out of 25, okay, 24 smoke, one do not. Okay. And out of those who do not smoke, out of those who do not have the disease, 15 did not smoke, and 10, and 15 smoke and 10 did not smoke. So if you take a look at this, we generated this table based on the fact that we are targeting the outcome. Okay. So I just wanted to take note of that. That's what we call case control study. Let me tell you this. The approach, the statistical methodology that we're going to use in the case control study may be different from the one that we're going to use in a cohort study. Okay. And that is the reason why we have to put into consideration what we base our sampling on. Here, the sampling was done with the respect to outcome. Now, we want to go into another one. When the sample was not done with the respect to outcome, but with the respect to exposure, which means I'm actually in my sample, I'm only targeting those who are exposed. Okay, so and that was why you see 25 are smokers, 25 are not smokers. Okay, and the question I'm going to ask them is whether they have the disease or not. Okay, so that is what it's saying here. Now, when I go to cross-sectional data, okay, this is when I just blindly go into the population. I choose 50 individuals. Okay. I'm not, when I choose 50 individuals randomly, I'm not interested whether they are exposed or they are, they have the disease, but I only figure out in the middle of the experimentation. So this is that. That's what we call cross-sectional study. So you need to be able to know the type of study you are embarking on for you to be able to know what appropriate method or statistics that you actually going to use. Okay, that is what I put here, using diagram. Okay, you can actually read that. Okay, that's all right. But there's something I needed to see. I wanted to look at, for instance, if I'm talking about here, I said, when you are dealing, I said, you can't use relative risk because we may be interested in getting relative risk. You can't use relative risk in a situation where you are doing a case control because you are the one that's actually determine the prevalence. And that's why, because we're looking for those who are already, okay, who actually have the disease. So that's it. You can't use relative risk, but you can use odd ratio. Okay, because researchers said the prevalence within the study. So when you know the type of studies within observational study, then you'll be able to know the appropriate statistical methodology that you actually going to use. We don't just apply statistical methodology without making sure there's a kind of conformity between the model we want to apply and the data structure. And that's why we mislead. Otherwise, we're actually going to mislead. Okay, so now in summary, for cross-sectional study, you can see not useful for identify cause and effect when you have a cross-sectional study. Okay, and of course, for case control study, it's economical. So if you read more, you're actually going to see, the benefits of each of that. And if you actually want to have reference here in case you want to have a better understanding of what we've been doing, there's a article by of First Class in 2020, Introduction to Observational Studies. Okay, and of course you can also review other literature too. Okay. Now, I put a question here. Take a guess. What type of study? I just want you to figure it out yourself. I just want you to think about it. You may not tell me your response now. What type of study finally provided conclusive evidence that smoking is a risk factor for lung cancer? Okay, we want to conclude our conversation. Okay, we want to link a study that we enabled us to link smoking to lung cancer. I just wanted to look at what we've done within the observational studies and be able to tell, okay, which one we think will be more appropriate. Is there any question for me? There's going to be a plan. There's going to be something that will come up over the weekend. If you check the announcement section, I'm actually going to send some information. Okay. This is what I got for you today. Make sure you also, before I go, I've been publishing my recordings on my YouTube channel. Of course, make sure it is spring 2026 in case you want to catch up with something that you missed initially. Okay, make sure you all stay safe. Have a lovely day. Bye for now, everyone.